So while she's doing that, I'll just reiterate that we are NIDUS, Lisa DeLuise and James Kobe in the background, in the back. We'd really like to thank all the people that made this program possible, which has been a phenomenal experience for us. I'd like to thank all the people who found the time to come as mentors. And I'd like to thank all the other teams from whom we learned a great deal. It's really a pleasure to be able to say all of that. So we're NIDUS Biosciences. Okay. We are, just very briefly, we're a University of Rochester spin-out. We are making what we call microbubble arrays, which are little reaction wells. There would be about 700,000 of them on an area the size of a microscope slide. We make them to play in the $18 billion biochip market, pardon me. I have to stand here. We already have product. We already have customers that we are providing product under academic material transfers. We have an inventory we are about to start selling, although selling will be at small scale. We have what we hope is a bright future, and we have lots of interesting things to tell you. So, and we also have 3 issued U.S. patents that cover the technology, with more to come. In my spare time, I'm a patent attorney. So, target market. The biochips market is an $18 billion market. Biochips sort of generally are miniaturized test sites that are arrayed on a solid substrate with a sensor. So you can imagine performing tens of thousands, hundreds of thousands, or even millions of reactions in a machine, on a chip, for gene sequencing, for proteins, for toxin testing, et cetera, et cetera. What this slide shows is that the biochip market is segmented within that 18 billion, which we're certainly not claiming to capture as much as we'd like to. There are 2 prime foci. The first, number 1, is the tissue arrays and cell arrays, where you dispense cells into the wells, microbubbles, and you grow them. The second market is labs on a chip, where you would integrate microfluidics so you can control how fluid flows so that you can get computer-controlled reactions. So, again, if you look at the upper left, you see that's what our microbubble array looks like. Let me go right to why it's better. And I have a fairly long list here. They're high-quality arrays that are made by semiconductor chip fabrication that simplify detection and that, for cell growth, favor days-long growth, which is very different from what current other competitive products are. But rather than read all this, there's the simple summary. What happens in our microbubbles stays in our microbubbles. In other words, the fact that they're bubbles that actually are made by gas expansion from a semiconductor template, the bubble shape is such that the fluid trapped inside the bubble circulates within the bubble when fluid is changed above it, but it doesn't wash out what's inside. So if you can imagine a cell in it, the cell is going to get washed out, and if the cell is secreting factors of one kind or another to condition the media to make it grow better, those are not washing out. And that is a major thing, and the thing that's really beautiful about this is we can make, at the same time, hundreds of thousands of these microbubbles because we have a template where we do what's called gas expansion molding. Okay, so here's an example playing in the cell array biochip area. So what you can see here is, on the top you see this is where we're seeding one or a few cells in each of the microbubbles and culturing them, letting them grow up over time. And you can see that's actual data from one of our microchips, where what you can see is that over time the green shows live cells, and you can see that the cells have grown up and that they've actually adopted different morphologies, which is really interesting because when you're looking at how one cell becomes multiple cells, you're looking at cell differentiation, and you're looking at how the cells interrelate to one another, and the ability to duplicate that in this kind of array is actually very exciting. Now, why do I say it's exciting? Well, it's not me saying that, it's because we already have multiple partners for these. And when I say partners, I mean people that have tried them and that like them and that want to buy them, although I will say that, like any other business, you can sell lemonade, but you'd prefer to sell it at a higher price than at a lower price. So we're in the process of doing customer discovery to learn exactly what the price points are, although the price points are actually quite significant, which I'll show in a minute. Another application, this is in rare screening biochips. So for example, new drugs these days are mostly biologics, which are antibody-based drugs. They're obtained by, say, by inoculating a mouse with the compound that you want antibodies against, screening millions of mouse cells, immune cells, and trying to find the ones that are producing the antibodies that you want. So our technology allows us to have screens of millions of cells and millions of microbubbles. Again, you don't have to take my word that this is exciting because we already have partners for these. Actually, James is an immunologist by predilection and training, and he and Lisa have spent about, well, in total, I think this technology is about 7 years old. We have 15 publications, $500,000 in non-dilutive funding, 3 issued patents. One real focus has been on antibody screening. So again, a big market, one that we have penetrance into. A kind of a fun one, but one that's really exciting in a lot of ways, is if a biochip is a sensor plus an array, there are people that are working to make the sensor using a smartphone, because a smartphone is a very complex piece of electronics which has a very sophisticated, high-quality camera that you can use for detecting what goes on in the microbubbles. So we actually now have a partnership going with a professor at the University of Illinois, which I grew up and went to school at, who had previous companies in this area and is really interested in taking our microbubble arrays and using them with cell phones for screening for cell growth and screening for a lot of other things. I think it'll be fun because he's enthusiastic but untutored in the sense of biological applications, but is a really good guy to work with. So again, we have partners who want to leverage those. Okay, so very briefly, what are our products? Because having said that we have a product and having said that we have customers, it would be nice to talk about what we're actually going to sell. There are companies that make arrays. You can see here, this is an Australian company that's making conventional arrays that are not microbubbles. They have pricing all over the map, but they're certainly selling within, say, $220 for 10,000 or 20,000 bubbles. Our target price is about $300 per 1,000 bubbles. The idea being that if you're screening for 1 in a million cells, you'd want about 1 million bubbles. That would be a price that we'll probably discount for early users, but at least it gives us a starting point in the market. Probably will cost less than $10 to produce. So we're talking about a significant margin. These are also uncoated microbubble arrays, uncoated MBAs. MBA not being a business major, but bubble array. We also have coated arrays and coated arrays plus sensors. Those will command a higher price margin. There I've taken our collaborators' photo, stolen it, and changed the label to be a smartphone sensor plus our microbubble array, which we expect to be quite achievable quite soon, although again, that will require happily lots of development. So to summarize, this is our team, Lisa, James, and I. Lisa and James are subject matter experts with almost a decade now of experience in this technology. I'm a PhD and a JD, IP attorney, 15 years of starting companies, some of which have succeeded, so serial entrepreneur. And I am very familiar with what it takes to make a biotech or a startup succeed, the major thing being listen to the customer. Don't think you know what they want until you find out from them what they want. And as I end, I used to surf when I was in San Diego, and snowbanks don't cut it. So thank you very much.